let's try to understand about what is machine learning. I think there are a lot of learners who are planning to learn data science. So whenever we are trying to learn data science, this machine learning topic is very, very important topic. Means like whenever you go to an interview, the very first thing, or we can say 90% of your questions closely come from your machine learning itself, whatever we are discussing right now. So now this going to be our introductory class on machine learning. So whenever you say machine learning, there are overall 4 different stages in machine learning. So the very first thing is like what is unsupervised learning? This is also going to be your interview question. And what is supervised learning? What is self-supervised learning? And what is reinforcement learning? So let's try to understand what is unsupervised way of learning. So whenever you are trying to get into your unsupervised way of learning, let's try to understand. Let me just give you a one-liner definition. If there is no specific output, then we call it as unsupervised way of learning. And then what is supervised learning? If there is a specific output. So if there is a specific output, we call it as supervised way of learning. And again, what is unsupervised way of learning? It is similar to your supervised learning, but we can say it is called as dark matter of artificial intelligence. So it is called as dark matter of AI, or even I can say it as it is a common sense to your AI. So now we all have a common sense. In the similar way, even our AI is also having a common sense. We call that as self-supervised learning. And the last one, we call it as reinforcement learning. So reinforcement learning also can be called as continuous way of learning. Continuous learning or continuous way of learning. So if you take humans, we humans going to produce all these 4 types of learning. We can produce unsupervised learning, we can produce supervised learning, we can produce your self-supervised learning, and even we can produce reinforcement learning. But here comes a very first question. So Kant, why we need to learn about machine learning? That is the very first doubt we have it. So the purpose of machine learning is to make a statement about future. If you are planning to make a statement about future, we knock the door of your machine learning. And even I can say this making a statement about future, also I can say this as I want to make a prediction. So if your goal is to make a prediction, so what is a prediction? Let us go in a very simple note. Let's try to understand in a human terminology or a layman terminology. Now I asked you a question. So now, for example, the question is, what is machine learning? You already have the knowledge, so you can respond to that question. You can answer that question answering. So you can perform question answering with the help of machine learning. That example. So if I want to create that question answering ability to a computer or to a mobile phone, so we can knock the door of our machine learning. All right. For example, now we play the chess game. So while we are playing the chess game, the more you try to spend time on playing a chess game, the better you are able to be an expert in playing the game. So if I want to create the same thing to a computer or to a mobile application, so we are able to knock the door of machine learning, and that too we need to knock the door of self-reinforcement learning. And another example. For example, now we all see that. For example, now I just gave an example. Now you are a very good artist. You can draw the images. So now you have drawn an image and I said, hey man, how this person going to look around 80 years? So when his age is like 80 years, how he look like? So what you will be doing, you are a very good artist. So you try to make him, you try to add more wrinkles to his face, or you try to add the white hair to his face, or again you try to make him bald. In this way, you are trying to do that. You have your common sense and you use that. For example, you are looking at my face and you want to draw. You are an artist, very good artist. And I asked you, hey man, if you don't mind, can you draw me like a kid? If you don't mind, can you, what you will be doing, how a kid look like? So you will be having more thicker hair and you will be removing the beard, you remove the mustache, and you try to make my face more smooth kind of thing. So it need to appeal like a kid. So we use our common sense and we do that. If I want to do those kind of activities, with a computer or with your mobile phones, or even we all see this in our Snapchat filters or in our Instagram filters. To do that, we need to use the knock the door of self-supervised learning. So again, another example, hey, no, it's not my task. For example, I want to say you went to a hospital and I'm looking at your reports. Means you are like having a huge amount of cough, fever, sneezing, and all that. So I just conducted multiple tests. After conducting multiple tests, I'm looking at your reports and I'm saying, hey man, you are having COVID, or you are having this particular viral fever. So based on the particular results, or not results, so based on the what exactly the kind of test we conducted, I am able to say whether you are having a what type of disease, whether you got a cancer or whether you got a fever, or you got like you don't have any health issue, like whatever you have it, we are able to understand just by looking at the reports. If I want to make those statements, means based on the particular data, if I want to say, hey, whether a person going to get this disease or not, to make those statements, so with our computer or with our mobile applications, we will be knocking the door of supervised learning. So what is a supervised learning? There is a specific output. Now, if you are conducting a test in a medical hospital, so what exactly needed? So you need to have a specific output, whether you got a COVID or there is no COVID, or whether there is a fever or there is no fever, or whether there is some flu or there is no flu, or whether there is some disease or there is no disease. We need to have a specific output to do that task with our computer or with our mobile apps. So now we need to go with supervised learning. And there is one more example, unsupervised learning. So let me take one more real world example in our day-to-day life. Now, for example, we all now what I'm doing is, like, whenever I'm not keeping well, or whenever I'm not, whenever I'm having like a huge amount of headache and all that. So what people going to do is, like, they try to give me, for example, if I'm not keeping well, let's take a simple example. I'm not keeping well at all. So then what my parents going to do? They try to give me something which I like it, something which I love it. So how they are able to identify? So based on my previous thing. So whenever I'm not keeping well, when these people gave me this, or whenever I'm not keeping well, if they say, hey man, I will be buying you this, or I will be getting you what you like more, what you eat more, what exactly you love more. So they want to give you something what you love more. Why? So now by giving that, you want to be happy. So are you going to come out of that particular mood? For that reason, what your parents do, they try to give something similar, or something similar to what you done in the past. So now if I want to make a statement based on the similarity, means like we don't have any specific output, something similar. So now what is that example? Now we all browse YouTube. So you clicked on a video, you liked a video, you shared a video. Your YouTube thinks, oh my God, this guy is liking this content, he's sharing this content. So what YouTube going to do? It's going to recommend similar content on top of your particular YouTube. Or it's going to recommend you on top of an email recommendation, or it's going to recommend you in Facebook, or it's going to recommend you in Instagram. Or for example, you went to Flipkart, you bought an item, you clicked on it into Amazon. So like you left the product, you're not buying it. Then what your Amazon going to do? It's going to recommend that similar kind of product. So now we are trying to understand based on this similarity. If I want to understand based on the similarity, then what I do, if I want to create that similarity based intelligence, or if I want to create that similarity to a mobile app or to our computers, we will be knocking the door of unsupervised way of learning, or no specific output. One more example where we can see this unsupervised. So now you go to a medical shop, you try to take a paracetamol. The medical shop people going to sell the bread. Basically, bread is an item of a bakery. So bakery people need to send a bread. But why medical shop people are trying to sell this bread item? So people who are having a health issue, people who are having fever, they are more likely to buy the bread. So unsupervised way of learning. So we call it as what? Similarity. If you want to make statements with respect to similarity, so if you want to create this kind of things to a computer or to a mobile app, we will be knocking the door of unsupervised. So now we had a very clear understanding about what we do as a humans. The same thing, if I want to create it to a computer or to a mobile device, we will be knocking towards these four things, which is unsupervised learning, supervised learning, self-supervised learning, and a reinforcement learning. So keep these points in the brain, so they may ask you in your interviews. And the next one is like, for example, now let's spend more time on what is unsupervised way of learning. As I said, unsupervised way of learning can be called as no specific output. If there is no specific output, we call it as unsupervised way of learning. So now let me take a small example. There is a kid. So now this kid age is somewhere around, we can say 3 years, and he is not going to school or anywhere. He is not going. So on a specific day, what the father done is he bought a basket full of fruits. Like he went to the shop and he bought a basket full of fruits. And he placed it onto the ground. So let's imagine the father placed the fruits onto the ground. For example, this is a cover full of fruits. So what kid done? He's looking at all these fruits and he want to play. So he rolled down all the fruits onto the ground. He rolled out all the fruits onto the ground. So let's imagine these are all the different types of fruits. And what this kid done? For example, he don't know English. He don't know like Hindi, or he don't know anything like the native languages. Like he is just like, he doesn't know, wait, this is called as apple. He don't know colors. He don't know red color, green color, blue color, whatever it is. So he don't even know the shapes and all that. So, but what he is looking at, so while he's looking at the fruits, and he don't even know that these are the fruits. Like he can see that. So now while he's looking at it, he's able to notice something similar. So our eyes are similar. So we are able to identify the similar patterns. So what he is doing is, he is trying to identify all the similar things, and he is trying to group all the green color fruits into one category. So what he is doing, he is trying to group all the green color fruits into one category. So he's trying to group all the green color. So why? Based on the color, you don't know this color is called as green, but based on the color. So then saying color means the kid don't know, but for you, like you know that. That's the reason he is trying to group all the green color similar thing into one category. After that, again, he started grouping all the red color fruits into another category. He started grouping all the red colors into another category. And again, he started grouping all the orange color fruits, into another category. So in this way, he started grouping all the fruits. So when he started grouping, taking the black color thing, he grouped it into green, red, and the orange. So suddenly the mother came and she gave him a fruit. Right? Why he left one fruit? So the mother gave a fruit. So he's looking at the fruit and he's comparing with green color, orange color, and the red color. So which one is more similar? He's trying to place it. Now here, see this. Now first, we are looking at the data and we are able to group them based on the similarity. So based on the similarity, we are able to take this and we are able to place it. So now we all do the same thing. Now for example, when we all do that. One such example is, now you don't know the material, let's imagine. For example, you want to learn a new course. Let's take data science itself. You don't even know what is supervised, what is unsupervised. You are able to see the PDF name data science. Hey, download it and store it into a folder data science. So we are grouping all the materials, all the images, all the PDFs into a category based on data science. You're similar. Based on the similarity, you're grouping it. Now, there is no specific output. Why there is no specific output? After a couple of minutes, the father is asking the kid, hey man, give me an apple. So now he grouped it all the red into one category, but he don't know what is an apple. Again, the father asks, hey, if you don't mind, can you give me a grape? He don't know what is a grape. Again, the father asks, hey man, if you don't mind, can you give me an orange? He don't know what is an orange. So we can group the data, but he never learned about what is an apple, what is an orange, what is a grape. Why? Again, within the green color, there are different types of fruits within green color. There are different types of fruits, again, within the red color. There are different types of fruits, again, within the orange color. We are unable to categorize it. That is a problem here. So now that's the reason what this kid is doing, or like the kid doesn't know what is an apple, what is a grape, what is a strawberry and all that. So the father decided, he already got 3 years. Now he can't just group it based on the similarity. Why? If we go to a fruit shop, hey, if you don't mind, give me that red. He can't ask the shopkeeper, give me that, give me that. He can't go and he can't ask it like that. He want to be specific. He can't just be random. Hey, give me that, give me that. For example, now you are able to see different materials in Telegram and all that. You are able to download it. But how you can read the specific thing when you have a specific learning, based on that you can read it. Now, after learning this topic, you can specifically read unsupervised, or specifically you can read supervised. In this way, you can do that. But when you don't have any idea, you can't read it, in a specific way. That's the reason the father decided, I want to train my kid in a specific way. So what he done? What is meant by this specific way? Let us go back. Now this is unsupervised. There is no specific output. He just grouped it based on the similarity. Based on that, he can make predictions based on the similarity. We all do that. So YouTube, one of the example where we use unsupervised learning, YouTube recommendations fall under unsupervised way of learning. So Instagram recommendations, the reels which you are getting suggested, or Facebook recommendations, or your Amazon recommendations, or when you go to a medical shop selling you the bread. So when you are buying one product, if you are buying a phone, they are trying to sell you phone plus screen guard. So all this comes into your unsupervised way of learning. So now what are the algorithms we use in unsupervised way of learning? One simple example I'll be telling you, we call it as K-means is an algorithm, or PCA, principal component analysis, is an unsupervised algorithm, or even we can use associate rules is also an example of your unsupervised way of learning. And the next one is, after unsupervised way of learning, we got supervised way of learning. What is the purpose of a supervised way of learning is, I want to train my kid with a specific output. Why? The kid is unable to learn in the first go, in the unsupervised. Why? There is no specific output, so he just grouped the data. Now the father decided, I want to train my kid with a specific output. What does it mean? So now he want to create a column called as label. So label of the fruit. So now he want to label it apple. He want to train him with the green apple. And he want to train him with strawberry. And he want to train with grape, green grape. So with these three things, with the 4 fruits, he want to train him initially. So now, how he want to say apple, green apple, strawberry, grape? So there are ways, like either you need to showcase an image you want to train him, or you just need to say, hey, this is apple, this is a green apple, strawberry. I want to either, on what basis? With the shape you are saying, with the color you are saying, there need to be some area to say, hey, this is apple, this is a green apple. On the air, I can't say, hey, this is apple. No one going to learn it. Hey, this is green apple. No one going to learn it. So the father decided, so this is called as output, or I call it as label, or even we call it as output. So this is the output learning, specific output. So now how this specific output depends upon the color. So when the color is red, we call it as apple. When the color is green, we call it as green apple. When the color is red, again we call it as strawberry. When the color is green, we call it as grape. For example, here if you look onto it, when the color is red, when the color is green, when the color is red, when the color is green, we call it as different fruits. Red apple, green apple, red strawberry, green grape. Now the kid is unable to learn. Why? So when the color, Papa, when the color is red, we call it as apple. Wonderful. When the color is green, we call it as green apple. Perfect, Papa. Then again when it is red, we are calling strawberry. Now I am confused. So if it is a red color, whether it is called as an apple or whether we call it as a strawberry, the kid got a confusion. Again, see, Papa, when the color is green, so we call it as green apple, and when the color is green again, we call it as grape. So now, how can I decide when the color is green, whether it is a grape or whether it is a green apple? Again, the kid got a confusion. Then again, the father said, okay, kid, try to take this. Now, it's not only just the color, try to look at the shape of it. All right, Papa. When the shape is round, for example, when the shape is round, red, we call it as apple. Perfect, Papa. When the shape is round and green, we call it as green apple. Perfect, Papa. When the shape is diamond, all right, or a heart shape, or a diamond shape, for example, or a heart shape, we can say. So we are saying, hey, see, the shape is, the father is drawing. If the shape is like this, like a heart shape or a diamond shape, then we call it as, if the shape is diamond, red, then we call it as strawberry. Again, if it is round, green, and the grape. Again, the father is again said, okay, Papa, now see, when the color is red and round, apple, I got it. When the color is green and round, green apple, got it. When the color is red and diamond, strawberry, got it. So now I can differentiate apple and the strawberry. But see this, again, round and green grape, round and green, green apple. So again, Papa, I got a confusion. How can I remember green apple and the grape? So again, the father felt, okay, no problem, kid. Now see this, you already got the shape. Let us take the size. If the size is big, round red apple. If it is again big, round green, again green apple. When the size is small, diamond red strawberry. Again, if it is small, round and green grape. So now Papa, I got it. So if the shape is, again, if the shape is, what is that, diamond, red, and the small size, we call it as strawberry. Perfect. Again, if the size is small, round, and the green. Okay, if it is big round, green apple. And again, if it is small round, we call it as a grape. I got it, Papa. So well. So now what exactly we call it as? This is output parameters. And this, we call it as our input parameters. So we call them as what? We call them as our input parameters. We are denoted as X. So we call it as input. Now, how exactly we are able to make a statement about output is? So now the output statement, we can make it with respect to the change in input. That's the reason the equation of supervised learning is y equal to f of x. What does it mean by y equal to f of x? The change in input, causes change in output. So now change in input causes what? Change in output. Now if you take all our examples, change in input. So in change in our body, so change in our body glucose, change in our body fat and all that, going to create a change in our output. Maybe like a weight gain, or maybe a diabetic, or maybe a heart disease, or maybe a COVID and all that. So change in our input going to cause a change in output. That's what the doctors are trying to identify through their test, whatever they are conducting. Now again, for example, the same philosophy happens in our examination. What is that? They give you a question and they expect you to write down the answers. So now why? So there is a specific answer to every question. It is not a random answer. There is a specific answer to every question. So now what a process your college people follow? They try to follow 3 stages. What are the 3 stages your college people follow? They try to go with training. So the very first stage is training stage. What they do in the training? They give you question and they give you answer. So in lines of our machine learning supervised learning, what is a question? Question stands for output. Question stands for your input parameters. So based on the input, what are the inputs? These are the inputs. When the size is big, when the shape is round, when the color is red, what we call it as? We are asking a question to the kid. He's saying, hey Papa, it is called as apple. So this is output. Answers are called as outputs. So now what we do, first we perform a training. We train our students with questions and the answers. After making our students to learn questions and the answers, the second stage is we try to perform testing. So what we do in the testing, we try to give only questions. So what exactly meant by questions? We try to give only inputs. So based on the inputs, the kids need to give the answers. So this is called as output or answers. So now we are giving only the questions in the testing examination. So this testing can be called as examination, or I call it as exam. So what do we do in the exam? You try to give the answers to the questions whichever we are asking. So once you are able to give the very good answers, then what we do, we go with the third stage, which we are calling it as evaluation. In the evaluation, we try to compare, so kid answers, KA, versus key. So what is key? Actual answers. When we are comparing kid answers versus the key, we are able to get what performance. For example, how many marks you scored it. If you are scoring very well, you learned it very well. If you are scoring very less, you learned it very less. So the same thing happens with the kid as well. So now the kid learned when the size is this, shape is this, color is this, we call it as apple. So the kid learned it very good. So now he say, Papa, I learned it so good, Papa. I'm tired. Shall I take a nap? The father says, no, you need to wake up and I will be giving you an examination. So now come on. When the color is called as red, when it is this, when is that. So what we call it as? The kid is answering, Papa, it is apple, it is strawberry, it is grape. If he is unable to answer, the father going to understand. No, he is unable to learn properly. Again, let me relearn him. So in this way, once he conduct an examination, if he is not learning it again, the kid need to be retrained or he need to be relearned. That is a process. Now the same thing we do in our machine learning as well. So this example is called as supervised learning. So what we are doing in a supervised learning, we are training our machine learning models. So with a specific input data and an output data. So it is learning it. So this data is called as cancer data. This data is called as heart disease data. This data is called as there is no heart disease. Whenever we are giving this kind of data to our supervised learning, it is remembering what is a heart disease, what is no heart disease. If a new data is coming in, it can say there is a heart disease or there is no heart disease based on the previous learning our machine learning made it. So how it is able to learn it, I will be explaining it in our another video, how the machine learnings are able to learn. It's not just with respect to historical data, but with respect to historical data and a mathematical equation. So now, if you look onto the supervised learning, the equation is y equal to f of x. So x stands for input. There is another name for the input, we call it as features. And this y is called as output. This y is called as output. So now change in input or change in features causes the change in output. Then what is f? So the f stands for mathematical equation. So it stands for mathematical equation. So the change in equation as well. So change in your performance of your learning. So now all these three things are very important. So the performance of a kid or the learning of a kid is dependent upon the mathematical equation, or here I can say the methodology in which way you are teaching it. Mathematical equation, what type of inputs you collected or the features. If I collected only color and the shape, the kid is unable to learn properly. So here I collected color, shape and the size. So he is able to learn better. So mathematical equation is important. And the third one, output. What label you gave it. When the color is red, when the size is big, when the shape is round, we call it as umbrella. Like he going to learn it, the kid going to learn the same thing. So now what output you are taking is also very, very important. So we call it as supervised learning. So now where we use the supervised learning. So now if I want to make a statement, whether it is a male or a female, I want supervised learning. So whether a person going to get a COVID or he may not get a COVID, supervised learning. Whether he is able to get a heart disease or he is unable to get a heart disease, supervised learning. Whether he is able to get whether he is able to pay the loan or he is unable to pay the loan, supervised learning. So in this way, we can use supervised learning for all these examples where there is a specific output. Now, what are the algorithms we use in supervised learning? We got linear regression algorithm. We got logistic. We got decision trees, random forest. We got gradient boosting, support vector missions, cat boost, light boost, extra gradient boosting algorithm. In this way, we got different types of algorithms. So what is the goal of all this? To make a specific output, to make a specific statement. So the life cycle of the supervised learning is, so first we need to train. We need to train with input and the output. So here the input is called as question and the output is called as answer. After training, you want to test. After test, you want to evaluate. And after evaluate, improve the learning. So you need to improve the learning. So this is the life cycle of a supervised learner. So this is a small example. Now, our entire school means like the way you learn in your schooling, the way you learn in your colleges, the way you are learning now, all this comes into the same steps. You train it, after they test it, after they evaluate it, after they try to improve your learning. So this is the cycle. And next one is your self-supervised learning. What is a self-supervised learning? We call it as common sense of AI, or even we call it as dark matter, or we call it as dark matter of artificial intelligence. So it is called as common sense, or even we call it as dark matter of AI. So now where we are using the self-supervised is in a very simple note. I'm giving, for example, we write an email. We write like 3 words. After 3 words, automatically your Gmail is able to auto-complete it. So what is an example of self-supervised learning is auto-completion. That is one example, auto-completion. It is able to predict the hidden pattern. So what is the purpose of self-supervised learning? So to predict the hidden patterns, to predict the hidden patterns. So in order to predict your hidden patterns, you are able to knock the door of self-supervised learning. What you are trying to predict? You are predicting the hidden patterns. What is a hidden pattern? Now I'm writing, hi, how are you? It is able to predict the hidden pattern, auto-completing. Or another example where we are able to use this self-supervised learning is, now I'm able to give my image, I'm asking it to convert into an older version. It is able to do that, filters. Or I'm giving my current image, I'm asking it to convert to a female, the same image. You can do that. So or you are trying to convert me into a kid. You can do that in the Snapchat filters or in the Instagram. How? With the help of self-supervised learning or the dark matter of AI. So it is predicting the hidden patterns, or we call this dark matter of AI as common sense. So now what are the algorithms we use in lines of this self-supervised learning is, we try to use BERT models, we try to use robot, we try to use your GANs. GANs full form is generative adversarial and algorithms, and so on and so forth. Now all these algorithms are used in lines of your self-supervised learning. So to make a statement about your hidden patterns. So it is a common sense. So now it is trying to predict the hidden patterns with the help of your self-supervised learning. And after self-supervised learning, we got one more, which we are calling it as reinforcement learning. What exactly meant by this reinforcement learning is, so now once you are able to learn better, once you learned car driving, so you enrolled in a driving school and you learned car driving, after that, what you are doing, you are trying to perform reinforcement. Reinforcement stands for continuous way of learning. So if you take your Tesla cars and all that, so it need to work on your continuous way of learning. What is continuous way of learning? Agent. So here agent can be human. So now we are the humans. So now what we do, we try to perform an action in an environment. So this environment is called as world, or this environment can be called as office, or this environment can be your girlfriend or your boyfriend or your husband or a wife. So your environment can be your ground, playground, right? Anything, or it can be any place. So now what you are doing, that is your environment. So now based on the environment, so what is your goal? Your goal is you want to maximize the reward. What is maximizing the reward? So now you are in an office. Your goal is like you want to perform well so that they are able to pay you better. They are able to hike your salary. Or you're with your girlfriend, you want to be very good with your girlfriend so that you are able to get married. Or you want to be with a boyfriend, or you want to go in a playground. So they're going to have you in the team, they're going to give you the prize, or they're going to make you to the as the first down in the cricket, whatever it is. Now you want to maximize your reward and you want to minimize your penalty. So now in order to do this, what we do in our continuous way of learning, once I learned a car driving, I want to drive better. So if I'm driving better, my friend's going to give me a car, or my friend's going to praise me, or my father going to give me a car, or I want to own a car, or I'm going to take a car safe to the home, whatever it is. So your goal is you want to maximize the reward and you want to minimize the penalty. The same thing we do in lines of our Tesla cars as well. So now once it learned everything, so it learned about, hey, this is the green light, you need to stop, you need to move, if it is a red light, you need to stop. Once it learned all this, so it need to perform continuous way of learning. What does it mean by continuous way of learning? It need to keep on learning. So like it need to reduce the accidents, it need to maximize the driving better, continuous way of learning. When we need to go for reinforcement learning is when you have less amount of labeled data. When you got less amount of labeled data. So what you do, when you have a good labeled data, you go with supervised. When you have a less amount of labeled data, we knock the door of our reinforcement learning. For example, we don't have a labeled data on how you need to drive for the next 10 years. You need to learn, you need to do mistakes, you want to correct it. That's how you will be learning, less amount of data. So that you are able to build experience. So the same thing with the game. So by playing more, you are able to build experience. So by doing data science more, you are able to get more knowledge. Continuous way of learning or reinforcement learning. So nowadays we are moving, or we are knocking the door of what? We are knocking the door of our reinforcement way of learning. So this is our reinforcement way of learning, so which helps us to make our models to learn continuously for the next 10 years or 20 years, so it keep on getting the intelligence. So now all these 4 types are more like humans. So we need to learn without a label, we need to learn with a label, we need to learn with the common sense, we need to learn continuously. So these are the 4 ways we can create it in our computers or in our mobile phones with the help of machine learning. So see you more on top of this videos. If you like this video, please do share and subscribe, and stay tuned for more videos.